Welcome back. So we are learning about the mesh analysis. So the next example that we are going to solve is related to the circuits with the dependent sources. So far we have learned about like how we can solve a circuit with the independent current and voltage sources. And like if a voltage source is shared between two nodes, it will become a super mesh like we discussed in the last example, okay, this one. So now let's have a look at the circuits with the dependent sources. For example, this is a circuit. It have basically one current source, one voltage source, and we have another current source here. Okay, why it is a current source? Because of the shape of the source. Okay, it's a basically dependent triangle. Okay, sorry, square here, and the arrow basically that represents a current source. So we have a dependent current source, and we have three loops here. Okay, our target is to find V naught. So V naught is the drop here. So basically that is 6 times of current flowing through this loop, that is I3. So 6 times of I3. So if we find I3, we can find basically the output voltage here. So our approach will remain same, okay, like we have learned in the last examples. Okay, define the loop currents and then get the equations for each loop. Okay, so if we have a dependent sources, okay, so we just need to write another equation for that, and we can get our desired uh, calculations, variable values based on that. So if you look at this circuit, the good thing will be that I will start with the independent current source loop, which is basically 2 milliampere. Okay, so through this loop, so basically actual flowing current will be the same. Okay, this one. So I can say that basically I2 is nothing, just 2 milliampere. Okay, so basically we get our first loop current directly. Secondly, if I come to the top loop, I1, again this is the a current source which is basically not shared between two loops. So we can again say that through this loop the current flowing will be basically the same. So I can say that basically I1 is nothing, I1 is the same, this current which is basically what, Vx over 2000. But here like I2 was a constant value, I1 is not a constant value, is a dependent value dependent on Vx. So then you need to find out what is the Vx. So if you look at the circuit, Vx is defined as the voltage drop across this 4 kilo ohm resistor. So we need to write the equation for this dependent variable. So if you look here, it's a voltage drop with this polarity plus minus. Okay, so it means through this 4 kilo ohm two currents are flowing. Okay, one is I1, that will be this current, okay, with this direction, and I2 is basically flowing, it will be in this direction. So we can write basically based on this that Vx basically will be what, because positive polarity is here and I1 is flowing towards this one, so I can say that basically 4 times of I1 minus I2, and we can plug in this in our main equation. Okay, so I1 basically will be what, 4 times of I1 minus I2 and divided by 2000. Okay, so all values are basically in k, so 2000 can be written as basically just 2k. Okay, so divided by 2, or if you rearrange this, okay, so this 2 and this will become 2, so I1 is equal to 2 times of I1. Okay, so I1 is equal to 2 times of I1 minus 2 times of I2, or this I1 will goes to this side, so it will be minus I1, so 2 minus 1, it will be I1 minus 2 times of I2 is equal to 0. So we have our basically equation, okay, for the second loop now. So using the dependent source, okay, we write that dependent variable equation and we can get a simplified equation for this loop now. So lastly we left with the third loop. So let's write the equation for this one. So we can start from any point. So for example this one, let's start from the voltage source. It will be minus 3. Then we have this here, so plus 2, which currents are flowing, I3 and I1, so it will be I3 minus I1. Then this one plus 6 times of I3 is equal to 0. Okay, so let's do it now. If we just rearrange it, so what we will get here, minus 3, 2 times of I3 minus 2 times of I1 plus 6 times of I3 is equal to 0. So we have here basically I1, so it will be minus 2 I1, then 6 and 2 plus 8 I3 is equal to minus 3 will go to the other side plus 3. Okay, so within now we have basically two equations, this 2 minus 2 I1 plus 8 I3 and I1 minus 2 I2. So in this equation we know that basically the value of I2, so I can plug in that value here to simplify this one. So that will give me the value of I1. I1 is basically nothing, 2 times of I2, and what is I2? 2. So 2 times 2, 4 milliampere. So I can get the value of I1. Once we have this, we can plug in here to get the value of I3. So minus 2 times of I1 is 4 plus 8 times of I3 is equal to 3. So 8 times of I3 will be what? 3 minus 2 times 4, 8. This 8 will go to the other side. So 3 plus 8, 11. So I3 will be 11 over 8 milliampere. So we got our all currents I1, I2, I1 and I3. Okay, so our target is what? To find the value of V0, which is basically nothing, 6 times of I3. So V0 will be 6 times of I3, 11 over 8. Okay, so 2 times 3 and 2 times 4, so 33 over 4 volt. Okay, that will be our V0 for this case. So this is how we can solve such examples. Thank you so much.